How's it, Dawn here? In this video, I'll be showcasing how a scanner works. And a scanner, I mean a scanner which is part of the compiling process of a programming language. So there's the lexer or compiler or scanner. I'm using scan in this case since it seems to be the most common term, most commonly used term, although any are fine. It converts the raw text into tokens, which are probably the smallest part of that you can actually use in compiling a programming language. It's the very first step. So I'll just be showcasing it to you just because I thought it'd be quite interesting, and of course I'll be using Swift. Right, so I'm just making a new template for my project. I'll choose the command line tool and I'll name this scanner. Scanner YouTube. Just leave it that. Right, let's start. So we've got a basic main function here. If we just open this, the console area. Okay, so we've got our little console. So if we just run this, just do a little sanity check, make sure it all works. And it's going to say running and hello world with a return of 0. That's perfect. We can delete the hello world and we can make a new file and I'll name this scanner. So then I'll make this a class and it will have a few variables at the start. It will have a private variable for the current, which is the current position in the source file it's looking through. This will be an integer, which will be 0. I'll make a private variable which is the start, which is another integer. All these will be used later for determining the position in the source file. We'll have a private variable which is the line number we're on, and this is for returning errors. We're not going to use up that much in this episode, but if I decide to do more episodes on how to make a proper language, then we will use this for error correction. I'm not sure though. And then finally we have a private variable source, which is just a string. And I won't set this to have a default value. I'll make an initializer. Right, we don't need to set any of the current start or line because it's all set to 0 as the starter initializer value. And we just need to set source. Then we're going to add a function scan token. Okay, we're going to have a let c, which is the current character we're looking at, called advance. So we advancing to the next character. Okay, and we're going to implement advance now. So look up advance. So in advance, it's going to return a character. And it's just going to go let c is equal to source dot get char, okay, and we're going to get the current character at current, and then we're going to go current plus equals by 1. So we're going to get our current character and then go to the next character, and we're going to return c. Now the string doesn't have get character. This is just a little extension I made to make. It's just a little quality of life extension. So I like to call this maybe types or something. And I'll make an extension. It's quite cool, Swift actually. This is probably one of my favorite features of Swift that I've never seen in another language actually, where you can extend either built-in classes like strings. So you can, like, it's almost like a built-in function or a variable, whatever. It's quite cool though. Sure, we're going to have character at. It's going to input an index. And that's going to be an integer. And it's going to return a character. And then we have index is equal to self.index. And the reason why I'm doing this, you don't have to. You could write everything, you could just do the normal way, the built-in way. But I personally don't like it. It's just a bit long. I mean, in every other language you have like just char at, or even better, you could use an index, but that's slightly more work. But yeah, it's quite cool. Just doing string.charrat. It's because we get because we use it quite often, this charrat. Anyway, we got advanced now. Then we're going to have and we're going to add a switch case. So switch C, so we're looping through all the different possible combinations of this character. So, and we're going to have a case, and if C is, let's say, left parenthesis, okay, then we're going to add a token, and this is where we actually convert raw text into tokens. And we're going to add a token left parenthesis. And the reason why this doesn't exist right now is we've got to add a token, and a token is just the smallest possible little, it's almost like a character for, it's just a single bit of information. It could be a boolean here with a value, it could be an identifier, or it could be a left parenthesis in this case. So we're going to add a token type for the first part. And token type, I'm not actually going to write all this because it's quite big. It's just a big enum pretty much. And it's just a big enum of all the possible different little things we might have. We have left parenthesis, left brace, right brace, dot, minus, semicolons, identifiers. Identifier, by the way, is like a function name, variable name, just custom name or something. We even have built-in things like print, return, self-true, lots of var, let, etc. So if we add we're also going to add a proper token, and so we add token, and this is just a class token, and the token it's going to extend from this very long name, custom debug string convertible. And this lets us have, it's just a really long complicated name for allowing us to have a default for having a prettier print. Just making us be able to print things with showing all the data. And I'll show you what that means actually later. But anyway, if we have let type is equal to a token type, and let lexer is equal to a string. I'll explain what these does. Literal is a any, and a line is, believe it or not, a line number, which is just an integer. And we'll make a simple init, not for the debug description though. In fact, we can actually not have a debug description right now. We can add that later, so I'll show you what it actually does. Okay, now I'll explain what these actually do. So we have the type, which is just the token type. We have the lexer, which is the raw data value, the raw text straight from the source. And then we have literal, which is the same thing, but later we have a string. So the lexer might be Bob, and the literal would actually be a string Bob. Now string isn't a great example, so let's say lexer is equal to 3.15. This would actually be equal to a number 3.15 as a float. Or maybe an integer, or maybe a string. It determines the real value of it. And that's very important later on for abstract syntax trees and the interpreter to determine what it is. Is it a string? Is it a integer? Is it a float? Because we do different calculations then. But anyway, that's not terribly important right now. So we go switch C, we add token. I'll go func add token. And in add token won't return anything. It will have two inputs though. It will have the type. And by the way, the underscore here means that I don't have to write type like that. Just makes it simpler to write. And then that would be a token type. And then we have the lexer, and then we also have to input the literal, which is a any. Now, by the way, the reason why I only have one input here, one argument here, and two arguments here is because I'm going to set literal to a null value as default. So we don't need two functions, one without a literal as an argument, one with. Just makes it slightly shorter, and let's take advantage of that Swift part. sure, if we have a let text is equal to source, okay, dot substring, this is another thing I'm going to add, substring, and this is going to be from, okay, from start to the current. And then I'm going to force unwrap it because it's going to return optional. So again, we're going to add a func substring, okay, and we're going to have from. And what's cool about Swift is instead of having to write start to end, I can write from, and that's just like that's just what we write as the argument name, but it's not actually the argument name, it's just the preview argument name. The actual argument name, we can name it something else. So let's say this could be start. 1 second. Right, this can be start, and it's an int, and it's start is an integer, and then to end an integer as well. It's slightly more user friendly than having to write start and end. Then we go do a quick guard statement to make sure start is within bounds. So we go make sure start is greater or equal to 0. Right, the end's go to be smaller or equal to self.count. Since we're in a string, we can do this, which is quite cool. And start has got to be smaller than the end. Is very important, of course, so you can't go out of bounds, else we return null. And that's why it has to return an optional string. There we go, and then we have the let, and if all goes well, it's let start index is equal to self.index, and it's going to be self.startIndex, okay, and offset by the start. And the exact same thing, but it just makes, look how much shorter it is. We can just go substring instead of having to write all this code ourselves over and over, because we use substring also quite a lot. We can go start index, sorry. And then we can, instead of writing start index here, write end index. Perfect. And then we can return a string of self, and we go start index dot and then less than end index. Perfect. Now we can go back to our scanner. And now that works. Right, so switch. I think I've done something wrong here. Oh, this shouldn't even be in here. Put that in the wrong place. Should be here. Right, switch must be exhaustive, and that. So we're just gonna add a default though. And for now, default will do nothing. It will just break. We'll add proper logic here though later on. But yeah, so in scan token, it will go switch. So left parenthesis, we'll check for the same thing for right parenthesis. And for now, these are all the basic ones. It's just add token for right parenthesis and just all the basic ones that only have one character. And I'll just paste in all of the 1 characters, which is just like left parenthesis, right parenthesis, brace, comma, dot, minus, plus, semicolon, and star. Right, so we're going to also, next we're going to add a more complex case, which is the not equal, and the reason why not's complicated, slightly complicated, it's very simple, but it's more advanced than just adding what I call bang in this one, but it's going to add a match. So the reason why this is more complicated is because we got to make sure that equal, it's go check for not equal as well, because that'll be bang equal then. So dot bang equals if we have an equal, and then otherwise it's just dot bang. And I just want to say that all this code, I didn't actually write it from scratch. I'm just following a quite cool book now. I'll give a link in the description. So pretty much it's all about how you make your own interpreter, but it's in Java. But so I just translated a lot of the code and changed some of it because I'm trying to so I replaced some parts, but mostly pretty similar. So I will give credit. So yeah, but yeah, it's very cool, very good, very cool. You should read it though, and follow it. It's been quite fun though so far. And I've maybe halfway through making my fully completed custom interpreter, which is quite cool. So I'll do the same thing with equal and less than, token, match, and we're going to check for equal again, and that is less dot less equal or dot less. There we go. And we haven't added match yet, but so we're just going to do one more for greater. This is going to be dot greater equal, and then dot greater. So match, all that's doing is checking the next character without moving our current, and we're just checking and returning the next character. So it's going to input a character. Right, we're going to input a expected character, which is a character. So in match, it's going to be, we're going to check if it's at the end. So, because if it's at the end of our source, then we can't check anything. Okay, it is at end as well in a second. So if it's not at the end, and then we add source.char at current, okay, is not equal to the expected character. So if the next character is not the expected character, then we return false. Otherwise, we go current plus equals by 1, and we return true. There we go. Okay, so we're going to add is at end. So is at end, okay, and all that's checking is just a little function. Is at end, it's going to return the current is greater or equal to source.count. So that's just checking within bounds. Yes, we want a return type, and that's just a simple boolean. And why are you complaining? Yes, that's a boolean, doesn't return a character. And I think that's all that. Okay, and next we're going to do dividing. Now dividing is actually more complicated, and the reason why is because dividing, it could be a comment, or it could be dividing. So we go check, we go match. It's still quite simple though. Match, we just check for slash. So if the next character is also a slash, then we just remove it all. So we go while, and we peek, okay? And peek is like match. It's basically match without the current. And we check if it's not a new line, because remember, comments stop when it's a new line. So if we just show that went wrong. Hello world. Next character, it's not comment anymore. We're just emulating that. And it might, and if you wanted, you could also do logic for what's it called, block comments or something. You could also do that logic if you wanted to, and add a new token for block comments. I'm not going to do that here, but you could. But if it is like that, then we is equal to advance. And by the way, the reason why I go underscore is equal to, it just it deletes the result. It throws away the result. And you don't need to do this, but Xcode gives a warning that we haven't used the result. And I'll just hide that. We'll add a peek though now. Right, so peek, we just go func, peek, and we go if is at end. Right, so if we're at the end, we return a carriage, I believe there's like carriage return or something. But it's kind of like no almost for characters. And then we can, and if we don't have, it's not at the end, we go source.char at current. Perfect. So then peek, can peek, and we just carry on peeking until we either reach the end of the file in which the comment's done, or we peek until we hit a new line, one or the other. But we do that, okay. So next we're going to do the case in which is just divide, which is simple, just a little else statement, and we do the normal add token, and we add a slash. And there's no comment because we just delete it. We just ignore it. We just go past it. So next is the kind of cases we can ignore. So that would be whitespace and a few special characters. So we have whitespace, we have a \r and tab. So we can ignore all these. We can just go break, and that don't matter. Then we have new line. So new line, we pretty much ignore it as well, but we must go line plus by 1. And then we can also do a case, which is the double quote. So we must check for a double quote. This is for strings. And to write double quotes inside a string without terminating the string in Swift, you must go / double quotes, which is perfect. Then we can write string. And how can I spell string correctly? String, and what string will do is we'll run a function. So we're going to make a string function. I'll just get everything inside a string, ignoring new lines unlike Swift. So we'll just get everything inside a string until it either hits the end of the file, which will return an error, or until it hits another double quote. So add a string, and we'll go wow. We'll peek to the next one, which similar to the comment actually. This part. It's just instead of checking for a new line, we check for an end quote. So we just go while the next character is, we peek at the next character while it's not a double quote and we're not at the end. Then we go if peek is equal to new line. Okay, then we go line plus equals by 1. Because remember, we can't use this new line part. It won't run this. It will just run the string. It'll carry on. But okay, and then we can go underscore advanced, so you can run advanced, so it goes the next character, and it'll just run this forever until it hits a double quote or end. And then we can check if is at the end. Then we can do some error. For now, I'll just do a print. But what you'd actually want to do is maybe use a logger or actually throw errors. Actually use the throw and error. But I'll just print out a simple unterminated string. So I'll just go self.line unterminated string. Very scary look sounding, but yeah, okay. And we're going to do an underscore here is equal to advance. And then we're going to go let. And by the way, the reason why is so we can, because this only peaks till before the character, it checks the next character and then it stops. So you got to go to the next quote character, double quote character. So you go advanced, then we can set the value is equal to source.substring, and from start plus by 1 to the current minus by 1, sorry. And the reason why we do this is to remove the 2 double quotes. So then we can add a token, and there's going to be .string. And we're going to input our value. So we're making progress. So we can add a new line there and string. Right, I guess we can test this actually. So I'm going to add a function called scan tokens, which is scan all the tokens. And it's just going to be while we haven't ended, then we can set the start is equal to current, and then we can go scan token. And then we can, after we scanned all the tokens, we can also, I guess we can return it. So you can return an array of tokens and return tokens. Do we have a token array? We should. Where's our tokens? Oh my goodness, did I forget to add a token array? What? Okay, so I've got, oh well, this is simple fix, just add a private var tokens, which is just an array of tokens, and set it to a default value so then the initializer doesn't complain. And then we can go tokens dot append token, and the type is going to be the type. The lexeme is going to be the text, the literal, the line. Okay. And then we can go return tokens. Then in our main function, we can go let scanner is equal to a scanner. And we're going to input source. So I'm going to make a source file. So I'm not actually going to hook up all the file management stuff. I'll do another video on that. But we don't need to do that. We can just say to string is equal to, I'm going to do 3 quotes. And the reason why is because first of all, there are 2 great reasons actually for using this. First of all, defining a file in this case. The first great reason is that it lets you add quotes inside here, which is great for writing strings. You don't have to add a custom a backslash, to write this, you don't have to do a backslash there, which is just kind of painful and messy. And also what's nice is you have to write 3 in a row to stop it. And also what's nice is it's all new line. You don't have to worry about new lines ending the string. And so what we can do though is we can, let's say we can set 3. No, we haven't hooked up numbers. So what is it? Hello world. And we can do less than, parentheses, that, greater than. Build failed, yes, of course it did, because I forgot to set the source. And in scanner, let's go embed this in a print. Print scanner dot scan tokens. And then we can run this. And you see, you can't see anything, it's awful. It just says scanner youtube.token, I hate that. So that obviously you can't see any data from that. So we're going to initialize, what's it called? I always forget. Custom debug string convertible, that's it. And then we add a stubs there. Okay, and we're going to set this so whenever Apple tries to, Swift tries to access debug, when it tries to print it uses debug description. So we can set this. So we're going to add it in these parentheses. The reason why is to make it so, because there's only a comma here and it's kind of hard to see between the commas, and we also going to add commas differentiate. Oh well, you'll see in a second, but you'll see what I mean. So we're going to add a type, and you see we have to add commas here, so it'd be very confusing between our commas and their commas. But we're going to add a lexeme. We're going to add a literal. And literal can be null, so I'll just add a default value as a string in null, instead of returning an error, in which case it's very often null. Oh well, now we can just run it and it should all work. There we go. So we have, oh yeah, I totally forgot to add an end. Okay, let's see. What have I done? Okay, so we can just add an end quote there. Yeah, that I think. Hello. Okay, there we go. Now string hello world. And we have hello world as the literal. We have less than, which is the less than character, and it's the literal is null, but it doesn't give any errors, which is perfect. So this is exactly what we're inputting, hello world. Right, that is perfect. So next I'm going to go back to scanner. So now we're going to work on adding digits, so numbers. Now we're actually going to do this in default value, and the reason why is because otherwise we'd have to have a case for every single different number, and that just is, that is just painful, having to write 1 to 9 and then a dot, which is just not worthwhile. So instead we're going to just check C dot is a number. So if it's C is a number, then we go number, which is very similar to string actually. Then else if C dot is a letter, then we do identifier, and then finally we go else, and we just print an error. This is there we go, unexpected character. And you could, if you want, you could even input C here, which is nice. And it's right. So first let's implement number. So I'm going to copy string, and I'm going to set this to number. Right, and in number it's similar, but so it's very similar, but instead of doing all this, we'll just check is a digit. So we'll just go peek and check if it's a number. It's quite funny, peek, but we'll check if it's a number and if it is a number, advance. Now the problem occurs when you get to a float where you have a dot, but this will be solved. So if we so end if it hits a dot. Let's say we hit a dot, we can go peek. If we check if it's a dot, then and peek next. I'll show you what that does in a second. Dot is number. Okay, so if the peek is a dot, and then after the dot there is a number, then it's a float. So you can just go underscore is equal to advance, and we can just skip it and carry on. And what scores, we can just run this again, and this will go do, and this while loop runs for all the parts after the dot, and this is all the ones before the dot. Before the decimal part. We can delete this advance here though, and let value sourced up substring start. We don't need to plus by 1 or minus by 1 here. Then let numeric value, which is an any, okay, is equal to a substring of value dot contains, and we're going to check if it contains a dot. I guess we can just do that. Oh, we can't do that. Okay, so dots, how do we do this? Contains. Okay, we can just do contains. That's nice. Dot, so if it's a dot, then we have a float substring or float value. So it's a float, we force it to be a float. If it doesn't have a dot, it's an integer, so we force it to an integer. And as you can tell, we don't actually tell it, we don't tell the programming language in the programming language whether it's an int or a float. It just determines it. So if it has a dot, it's a float. Right, so then we can just do that and force unwrap this. And can I force unwrap? Let's just fix all that. And there we go. We can add a token now number and numeric value. And that is perfect. Now all we have to do is peek next. And peek next is similar-ish to peek, slightly different though. Private func peek next. Okay, and it's going to return a character. Okay, and if the current plus by 1, so he's checking the next character, is greater or equal to source.count, so we're out of range, then we can't use is at n because that checks our current position. Then we return \0, and otherwise we do source.character at current plus by 1. And so there's just a little guarding, just to make sure you don't get an unknown value or out of range value. Right, so I guess we can test this now. So let's add 3, we could add, let's say, I guess we don't have that. What is it, 3.14159.618? That's pi, I believe. There we go, and You see it has a string value, but sadly it gets cut off. It gets slightly cut off with converting it to a float, because a float doesn't have that kind of precision. But yeah, it does round it actually, which is quite cool. So if I make this 9, it will be 97. It's quite cool. But anyway, now we can add an identifier. Identifier, by the way, is either a keyword like if or break. You see all these pink things in Xcode, they all highlighted pink, they keywords. So either that or the blue ones, some of the blue ones like a func number or variable, all the blue ones are kind of variables or functions, they're all custom names. So we're going to, that's an identifier, we call it. Right, so it's either a keyword or just a normal identifier. So in identifier, so we're going to check it. So in identifier, we're going to go while peak dot is a letter, or peak dot is a number. Then we advance. Okay, same underscore trick. We're going to go let text is equal to source dot substring. Okay, it's going to go from the start to the end. To the current. End doesn't exist. To the current. And if it fails, then we're just going to do nothing. And let type is equal to scanner dot keywords. This is a list of all the keywords, which I'm going to initialize in 1 second. It's just a dictionary. So we can do this, almost like an array. I love dictionaries in Swift. They do it very well. And so if it's a text, so if it doesn't exist in the keywords, then we set the type as an identifier. Otherwise, we set as the keywords a value, which I set. And we'll see that in a second. And otherwise, we'll add a token type, and then we'll add type is equal to dot identifier, no autocorrection if I get something wrong, identifier. So if we have an identifier, then it's text, otherwise it's null. Right, and now let's add keywords. So I'm not going to actually write it because there are quite a lot of keywords here. So I just paste it in. It's just a dictionary, so the key is a string and the value is a token type, and you see I'm mapping like and to and, system to system, component to component. By the way, I want to make some entity component system programming language. I think that would be quite funny and quite cool. Swift inspired one. So I'm going to have systems and components, and systems do the functionality, components do hold all the data. So that's why I'm adding it here. But of course you can change it however you want. I'm having elif, else if, false, for, all the normal stuff. Is, print. Yeah, we have all the normal. And print is actually a keyword in this language. This is based on the language LOX, which is done by the original creator. But yeah, so now we have a letter. And I think it's actually done now, which is exciting. So let's say we can add in my language you'd write it maybe like this, system Bobby is equal to, I guess we can do that there. Right, we're going to have a function in here, and it's going to be a start up maybe, and there like that, and then we could write that, and then in here it would go print, and it would print out hello world. Obviously this won't actually print it out, but it will print out all the tokens, which I think is very cool as well. Oh, come on, just delete that white space and that one. And you see we have a system, which is a system identifier Bobby, left brace, we have left brace function, that's perfect. Identifier, which is a startup. Left brace again, print, which is an actual keyword, string, hello world. Then right brace, which is just a right brace again, which is no. It's perfect, yeah. Well, I hope you enjoyed this episode, and I'll see you next one. And please comment if you want to see more If you want me to show you how to make an abstract syntax tree or the rest of the interpreter, I'm not sure though. We'll see. Oh well, I hope you enjoyed this video, and if you want to see the original creator who did it all in Java, then you can click and link the description. It's a very cool book. I recommend checking it out. Oh well, yeah, I hope you enjoyed this, and I'll see you next one. Bye!